This is an EMI question. Here we have a loop of wire that is being put through a magnetic field at constant speed. We're going to find out how the induced voltage in the loop varies with time. So we have to draw a graph, and let's assume that anti-clockwise is positive. So let's start with the original situation. In the original situation, the loop is outside the field lines, so there's no magnetic flux linkage and the voltage is 0. Now at this point in time, the loop is pulled through at constant speed, and eventually it's going to cut one of the magnetic field lines. It's going to cut them at constant speed because it has a constant velocity. So therefore my magnetic flux linkage is now not 0 and my voltage is not 0. Now, the important thing is we need to find out which direction it's traveling in. And we use Fleming's right-hand rule to do that because this is electromagnetic induction. Now my force is to my right because the conductor is being pulled to the right. My magnetic field is going to point down. Okay, it's going to point down. And my current is going to stick out in the Fleming right-hand rule fashion. So you can see, I'm going to have to contort my hand to do this. You see that the current is going to flow this way, right? So it's going to flow into the paper. So it flows into the paper as such. This is anti-clockwise. So there's a positive voltage here. And this positive voltage is going to be sustained until all the field lines are inside the loop. So now all the field lines are inside the loop. So my magnetic flux linkage is 0. Nothing's been cut. So if nothing's been cut, my voltage is also 0. So therefore, get a drop in voltage, back to 0. Now the field is smaller than the loop. So it's going to be inside the loop for a while. Eventually, it's going to hit the other side, right? It's going to hit the other side. So my magnetic flux linkage is not 0, so my voltage is also not 0. But which direction is it this time? Well, my force is still this way. My B field is still going down this way. I'm not going to twist my hand again. But then my current, we know, is going to go into the paper. But because now it's on the other side, you see that the current actually now travels in a clockwise manner, which means that my voltage is now negative. Now again, because it's at a constant speed and the width of this magnetic field is the same, the width of these two in time are also the same. Eventually, your field lines are going to fall outside of the loop. And here, the flux linkage is 0, so my voltage goes back to 0. And that's the graph. And so my answer, therefore, is